Hello students, welcome to the next session in the cryptography and network security module 2. In this session we are going to look into a defilement key exchange, but before we learn what actually the key exchange is, we are going to look into the primitive roots. So what actually a primitive root is, right? So this is a basic principle that is required in order to understand defilement key exchange. Let us consider there is a prime number and this prime number pp. So here there is no requirement like RSA that the prime number should be very large or small, something like that. You can consider any prime number, let that prime number be x. And primitive root. So the primitive root I'm considering here x to be the primitive root of p. Then, if I want to tell that x is a primitive root of p, then what is the condition that x must satisfy? So, x must satisfy the condition that x power n mod p, it should give results such that I should be getting values from 1 to that p minus 1, whatever p is that p minus 1. Suppose if p is 5, then, when I take this modular operation, when I perform this modular operation, I should be able to get values from 1, 2, 3, 4 as its reminder, right? Now, what is this n here? This n is nothing but any value from 1 to p minus 1, fine. So, also when I say this 1 to p minus 1, care should be taken that these values whatever we get, it should be non-repetitive, that is they should be distinct, right? See, if I get 1 and then next time for n equal to 2 if I get 2, and say next time n equal to 3 I'll be getting again 1. So that is not that I should not consider. I should be getting values from 1 to p minus 1 and all the values should be distinct. So that is what a primitive root is. Right? So for a given prime number, I can say that there can be more than one primitive root. Right? So having learned this, let's see take one example. Let us try to find the primitive root of p. So what should I do? I should perform this x power n mod 5, right? So what is this x? X can be any value from 1 to np minus 1. So this is my x. In some textbook you can also see this as alpha, fine. And these values, what are these values? These are my n. So now when I consider x equal to 1, when I consider x equal to 1, we know that for any power of n that you take, right? So the result would be 1 only here, right? Because 1 power 1 is 1, 1 power 2 is also 1, 1 power 3 is also 1, 1 power 4 is also 1. For all these values, right? So you will get 1 only. So 1, 1, 1, 1 is what you get. It's not a primitive root, right? Because I should get values from 1 to p minus 1 and it should be distinct. Now let's take x equal to 2, right? Or x equal to 2. So when x is equals to 2, for n equal to 1, n equal to 2, n equal to 3, n equal to 4, I should be applying this formula. So 2 power 1, mod will take, I'll get 2 only, 2 square, 4. If I take mod, it will be 4 only, 2 cube, 8. If I take mod, I will get 3, 2 power 4, which is 16, right? When I take mod, I'll get 1. So I'll try to fill these values. 2 power 1 it is 2, 2 power 2 it is 4, 2 power 3 it is 3, 2 power 4 it is 1. You can observe here. So what I've got? I have got all distinct values and these are from 1 to p minus 1. So I can say that 2 is one of the primitive. 2 is one of the primitive. Like that, I should be doing it for 3 as well, x equal to 3. Now 3 power 1, 3 power 1, if I take mod, 3 only will get 3 square, 9. If you take mod, you will get 4, right? 3 cube, it is 27. If you take mod, you will be getting what? 2, 5. Likewise, 3 power 4, which is right 81. And we take mod of this, you will be getting 1, right? Correct. So now fill this. what you are getting? 3 here, 4 here, 2 here, 1. So you can observe again it is distinct, right? So which means 3 is also primitive root. Now try it for 4. I have to check for all the values, right? I have to check for all the values. See, if I'm using this in Diffie-Hellman, it's in a different, that's a different part, right? Do we have to find all primitive roots? No, no. There we will be requiring only one. But here, since you're learning what actually primitive root is, I'm making you to derive all the possible primitive root for the given number. Right. Now let's try for 4. 4 power 1, it will be 4 only. 4, 2, 16. So you'll get 1 as a reminder. 4 cube, 64. You'll get 4. Right. See, 4, 1, 4. So this value is repeating. Yes. So 4 can't be the primitive root. So what are the primitive roots of 5? For 5, the primitive roots are 2 and 3. If I'm doing the same for Diffie-Hellman, then I'll be considering either 2 or I'll be considering 3. Since 2 comes first, I'll consider 2. So this is about your primitive root. So for a given prime number, primitive roots are those numbers which produces reminders from 1 to p minus 1, right, without repetition. Now let's take one more example. Let's take p is equals to 7, right? So now x I have to take 1. So 1 you it will not be, right, as we see. Let's take x is equals to 2, right? Now I'll be taking up to 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, right? So what will I get? Will I get the primitive root? Is 2 a primitive root? 2 will be 2 only. 4 will be 4 only. 8 will give me 1. 16 will give me what? 2. So this is also not a primitive root because 2 and 2 is matching here, right? Now let's take for x equal to 3. Now 3 is 3 power 1, 3 square, 3 cube, 3 power 4, 3 power 5, 3 power 6, right? Now 3 power 1, it is 3 only. 3 square, it will be 2, right? What is 3 cube? 3 cube is 27. And when you take 27 with respect to, you will get again, 6, right? You'll be getting 6. So what is 3 power 4? 3 power 4 when you take, you will be getting 81. So 81 divided by 7. So you're going to get 5, I think, right? So you'll be getting 5. So okay, it's 4. So you're getting 4. Now and then you do 3 power 5, right? 3 power 5 when you do it get 243. And now I have to take the reminder. So mod I will take. So when I take mod, what is that I get? Right? What is that I get? 343. So 243. Right? So 3 power 5. 3 power 5 is 243. Right? Divided by 7. 4 into 7 minus 243. So it's getting 5. So it's 5. Now 3 power 6. What is 3 power 6? It is 729. Right? So what is the mod that you are going to get? We'll get 1. Right. See, is it distinct? Yes. So x is equal to 3 is your primitive root. Now try for x equal to 4. X equal to 4 is not a primitive root. Guys, listen. You can note this, right? When x 4 is not a primitive root of any prime number, not a primitive root of any prime number, primitive root of any prime number. So you can consider this, and straight away you can skip calculating for 4. Now what I'll be doing, I'll be calculating for x equal to 5 now, right? When I do it for x equal to 5, 5 power 1, 5 square, 5 cube, 5 power 4, 5 power 5, 5 power 6. Right, 5 power 5 is 5. 25 will give me what? 4, right? 5 cube will give me what? 125. So it will be 6. Fine. If this is 6, right? 5 power 4 gives me 625. So 625 gives me 2, and 5 power 5 would give me 3125, right? 3125. So that gives me 3. Good. So far we are getting all distinct, right? So what is that we are going to get? We are going to get 1 again. So again, if you see, it is distinct. So x is equal to 5 is also primitive root, right? Now calculate for x equal to 6. 6 power 1, 6 square, 6 cube, 6 power 4, 6 power 5, right? 6 power 6. 6 power 6, 6 power 1 will be 6 only, right? 36, it will be 1, right? 6 power 3, so 6 power 3, it gives me 6, right? So number is getting repeated, 6 is not a primitive root. Therefore, what are the primitive roots of 7? For 7, the primitive roots are 3 and 5. So likewise, you can find primitive root of any given number, right? Thank you, students. We'll meet in next session.